Exactly the same principle that applies to rectangular distributions applies to triangular distributions. Let's look at this example. The amount of petrol in my tank is always between 5 litres and 40 litres, and it normally has approximately 30 litres in it. Let's just quickly draw this out. The minimum is 5, the maximum is 40, and the average is normally 30. Now this is where we need to do a continuity correction. I only know the amount of petrol to the nearest 0.5 litres. What is the probability there is less than 20 litres in my tank? So we need to adjust for only knowing to the nearest 0.5. So the amount that we'd know below 5 would be 4.5. So the cutover point in here is going to be 4.75. And again, the amount above 40 would be 40.5. So the amount in here is going to be 40.25. Now the reason we've gone to the outsides of these two numbers is we know it's going to be between 5 and 40. So we want to find the smallest number that rounds up to 5 and the largest number that rounds down to 40. Now 30 could be anywhere between 29.75 and 30.25, but we don't know where, so we'll just leave that exactly in the middle where it already is at 30. So we now know our A value, our B value, and our C value. Now it asks us to find out the probability there is less than 20 litres in the tank. So 20 is going to go in here, and the area we want is this. In order for there to be less than 20 litres in the tank, it needs to not round to 20. So the cutover point between 19.5 and 20 would obviously be 19.75. So that is our X value that we're going to be using. So now that we have all of our values, we can substitute them into the formula. Now this is on the upward slope, so we're going to be using the upward slope formula. So it's going to be 2 brackets x minus a, so 19.75 minus 4.75, divided by b minus a, which is 40.25 minus 4.75, and c minus a, which is 30 minus 4.75. Now we can type this all into the calculator and we find out that it's 240 over 7,171. Now we've got to remember that this is the height and not the area. We now need to work out the area. We know that this is equal to half times the base times the height. So substituting in the information we know, it's a half times the base is the difference between 4.75 and 19.75, so that is 5, times the height, which we just worked out to be 240 over 7171, which again, if we type into the calculator, we find out is 0.251 rounded to 3 significant figures.